with student ID 2025-3101 from Class C Information System Major at ITPLN. Today I would like to present my statistic and probabilities lab report focusing on correlation linear, regression, and hypothesis testing. I use SPSS and RStudio to analyze our dataset, find meaningful instinct about screen time, app using, and data computation. Let's dive into the result. So, uh, first, I analyze in the relationship between screen on time and battery drain using the simple linear regression. The question was, doesn't screen time significantly impact battery consumption? The answer is defined yes. Look at the result, the correlation here. R is 0.829, indication a very strong relationship. The R square value show the screen time explaining is 68.7% of the battery drain variance with a significancy level of 0.000, which is the way below our 0.05 threshold. This impact is highly significant. Our regression equation relevant that for every single unit in scarce instant of on time, battery drain significantly increased by 20.407 units. Next, I conducted a multiplied linear regression to see how the apps use time, screen on time, and user age simulation affect daily data use. It's interestingly when tested together, they don't have a significant effect overall. However, when we look at them individually, only app use time has truly significant impact with significant value of 0.000 and positive coefficient of 3.122. On the other hand, secret one time and user age were not sig- statistically significant in the predicting daily data use. Based on the model, if we have a 25-year-old user who use application for 120 minutes and has 4 hours of screen time, our regression formula predict the daily data consumed to be approaching 507.84 megabyte per day. Moving on to the correlation analysis, we want to know the external relationship between app use time daily data use. The person correlation convenience came out to 0.942. This means there is extremely strong and positive relationship. In simple words, the more time you spend using apps, the more daily data you consume. You can see this, the graphic. I also calculate the correlation between app using times and screen on time. The person confidence here is 0.821. They also increase a very strong positive relationship, which makes perfect sense. More apps use naturally leads to more secret of time. The screen on time, both tests is highly significant with value. After that, We finally talk about the hypothesis testing. Use the one sample t-test. For the first case, our null hypothesis is h0 instead of the average of the variable x equal 0, while the alternative hypothesis or h1 instead it doesn't not equal 0. We can see here. And our sample consistent consists of the 20 data point with a mean of 72.950. The t-test yielded a very high t-value of 13.624 and a sacrifice level of 0.000 since the sacrifice is much longer than 0.05. We reject H0 and accept the H1. This proves that the true average is significantly different and much higher than 0. We applied the extensame method for the second case, testing two separate variables x1 and x2. Again, the value of 0. Both variables have 11 samples, with x1 average is 70.45 and x2 averaging 72.73. We just like before the both the saw significant value of 000. Therefore, we reject the null hypothesis for both variables, concluding their average are statistically and significantly different from 0. That's conclusion my presentation. Thank you so much for your time and attention, and thank you.